Algebra 1 students, Ms. Richardson here. So I thought I would just go over some problems for you as your test review. So today is Tuesday the 17th and you have your next test tomorrow, the 18th. So make sure you log on and you take your algebra test tomorrow, the 18th. Thursday is a makeup day, so no zeros. Take care of all those zeros, you guys. And then Friday is a service learning day. So hopefully you'll receive information about that very soon. You'll actually come to my content page, my Canvas page on Wednesday or Friday to figure out there's the 6 choices that you're given and you're supposed to complete 3 activities. And then you're going to go into your Infinite Campus and log those hours. So anyway, we're supposed to get all that information to you, so I'm sure it's forthcoming. So let's look at some of the problems that we need to go over. All right, so on the first one, we're not allowed to multiply these the way they are because the first number is a square root and the second number is a cubed root. So we're going to use what we learned about exponents and radicals, and we're going to convert this. So remember that the numerator is staying with that base, which is the 5 is going to become the base. So since 5 in the radical is to the first power, the numerator is a 1. And since the number in that little section of the radical is a 2, we turn the square root of 5 into 5 raised to the 1/2 power. And we're going to multiply that by 5. Since it's to the first power, 1 is our numerator and our 3 is our denominator. So now we have 2 numbers that have the same base. So what is the rule for the exponents? We're going to add them. So now we're going to add 1/2 plus 1/3. So we need common denominators, of course. So we're going to use the denominator of 6. So that becomes 3, 6 plus 2, 6. And so the final answer is 5, because we don't multiply our bases, right? We just bring our base over. So 5 to the 5/6. So that is the answer to the first one. All right, so remember that a square root radical, square root, basically becomes an exponent of 1/2, right? So let's ignore the big square root for a second and just look at what's on the inside. So just like we converted this 5 right here, we're going to do the same thing. We're going to pull out that 2. Since it's to the first power, that 1 is going to become our numerator. The 3 becomes our denominator. And then the square root is always going to be an exponent of 1/2. So now we have a power raised to a power. So what is the rule on multiplying power or having a power raised to a power? The rule is you multiply those exponents. So 1 times 1 is 1 and 3 times 2 is 6. So that is the answer. Number 3, since none of these radicals match, we have to try to make them match. In other words, we're going to break them down. So we're going to think of what is the biggest number that is a factor of 72. So we could go through the list. That isn't 72 doubled, 36, right? So this is basically square root of 36 times 2. Well, the square root of 36 is 6. So 72 becomes 6 square roots of 2. Now, if I didn't pick 36, if I picked another number like 9 and 8, well, 9 is a perfect square, so that would become square root of 9 is 3. But then 8 could be 4 times 2, right? And isn't 2 also a perfect square? So the square root of 4 is 2, so I'd bring that 2 out.
LeBron, please come to the front office. Penelope LeBron.
So I would bring out the square root of 4, which is 2. 2 times 3 is 6. So we would also, in that way, get 6 square roots of 2 as well. So however you break it down. All right, so now we're going to subtract 8, which I already said is 4 times 2. Well, the square root of 4 is 2 square roots of 2. And then 128, well, not really sure what that is actually. So what would be half of 128? Oh, that'd be 64, wouldn't it? So this is going to be 64 times 2. Well, isn't 64 a perfect square? So the square root of 64 is 8 square roots of 2. So now that the radicals, what's inside the radicals match, we can combine those coefficients in the front. So 6 minus 2 is 4, and 4 plus 8 is 12 square roots of 2. And that's the answer. And if you have a good calculator, if you plug all that stuff in your calculator, it'll spit out that answer, 12 square roots of 2, but it's good to know how to do it even without a calculator. All right, number 4, we can't, well, yeah, we can multiply these the way they are. All right, so we can multiply what's on the outside and we can multiply what's on the inside. So 2 times 6 is 12. And square root 8 times square root of 4 is square root 32. So now we need to break down 32. So I'm gonna, where can I write? I guess I'll come up here. All right, so square root of 32, what is that? 4 times 8, well, I know 4 is a perfect square, and I know 8 contains a perfect square, so I bet there's a bigger one. So what about 16? Isn't 32 16 times 2? Yep. And isn't the square root of 16 4? So square root of 32 is 4 square roots of 2. So we're going to convert this to 12 times 4 square roots of 2, and then 12 times 4 is 48 square roots of 2. And then to double check that, we can just plug it in our calculators real quick and say 2 square root 8 times 6 square root 4, and the answer is 48 square roots of 2. Now, if you don't have this particular calculator and your calculator turns your answers into decimals, then you can't use that calculator. So this one is a great one. Hopefully most of you have it, but you can't answer that as a decimal, okay? All right, I'm gonna get rid of everything on the screen. All right, now we're gonna do number 5. So number 5, basically, I know I don't have any directions on there, but we want to rewrite this as a radical. So just like we did on number 1, kind of the opposite. The numerator stays with the base. So the numerator of 2 stays with the base, and the denominator becomes what goes right there. Now that's not quite simplified yet because we can square 4. So I just said it. We can square 2. So the final answer is the cube root of 4. Cube root of 4. Number 6, write an equivalent expression. So basically they want you to recognize that you can go ahead and cube 1.03. So I could rewrite an equivalent expression 1.03 cubed to the x power. Okay, and those are equivalent if I did the function of f or function of x. And then if I want to go any further, I could go ahead in my calculator and raise 1.03 to the 3rd power. And then that would be what goes in that parentheses. Well, let's just do it. So hopefully you have already done this, and so you're just checking your answers. That would be the best thing for you to prepare for your test tomorrow. So this is going to be about 30 times 1.09 to the x. So those 3 expressions are all equivalent. Number 7, what does the y-intercept tell you about a graph? Well, any graph, the y-intercept tells us our initial value. Initial value. Where do we start? Okay, that's what the y-intercept tells us. Because when x is 0, that number is the y-intercept. It tells us when x is 0, what number we have to start with. So number 8, bottles of water. So we have a bottle of water. Originally, there were 50 grams of water in the bottle. it evaporates, the water is evaporating at a rate of 18% per day. So is the amount of water going up or down? So if we graph that, that would show a decrease, right? A decay. What would be the y-intercept? So remember what we just said, the y-intercept is our initial value. So the y-intercept on this graph would be 50. And then would the graph show growth or decay? So, not, I mean, it's not really decaying, but yeah, definitely not growth, right? So it would have a negative curve to our line. All right. So y-intercept is our initial, so 50 grams, and the graph would show decay. Number 9, the number of bacteria in a sample increased by a factor of 2 every minute from 9:05 to 9:55. The function shows the number of bacteria in the sample after X minutes from 9:05. So what would be the domain? So at 9:05, how many minutes would we be from 9:05? 0, right? And then if we're going to stop at 9:55, how many minutes after 9:05 is 9:55? Well, that would be 50 minutes. So that is the domain. So that number, that X right there, represents the minutes from 9:05. So at 9:05, that has to be 0 because it is 9:05. And at 9:55, it's 50 because that is 50 minutes after 9:05. That's what 9:55 is. You understand? I hope so. All right, so number 10 is asking which of these functions, so we have a red line, a blue line, and a green line. Which of these functions has all real numbers as its domain? So domain, remember that is your X values, right? So the blue line definitely has a stopping and beginning point. And then the green line does also, but the red line shows that it goes on forever. From negative infinity to positive infinity, right? So it would be f of x, or in other words, the red line. So see, they're all kind of labeled. This is g of x and this is p of x. So this red line is considered f of x. Good deal. Number 11, Sheila invested some money at a fixed rate of interest compounded daily, or not daily, annually. What was the average rate of change of the value of Sheila's investment from the second year to the 5th year? So basically, they're wanting us to figure out what the Y values are if X is in the second year and in the 5th year, right? So we're just going to plug that straight in our calculator. 400 times 1.01 raised to the second is equal to 40804. And then we're going to plug in a 5. So 400 times 1.01 raised to the 5th power is 420.40 approximately. So now we have to find the average rate of change. So remember, we're going to do the change in Y over the change in X. So 408, so 420.40, so 420.40 minus 408.04 is 1236 over, what's 5 minus 2? 5 minus 2 is 3. So we're dividing 12.36 by 3. And our answer is $4.12 per year, because that's what they are, years. So the average rate of change is $4.12 per year. Got it? All right, number 12, compute the average rate of change from x equals 2 to x equals 4. So we're kind of doing the same thing. So we're doing from 4 to 2. So we're going to do the change in y over the change in x. change in y over the change in x. So remember, x is already labeled, but f of x can represent y. So our second y value is 8 minus our first y value over our second x value is 4 minus our first y value. So I know the denominator is 2, and then the numerator is going to be negative 120. So now negative 120 divided by 2 would be negative 60. So whatever scenario this is showing, they're decreasing by 60 every, whatever, I don't know, every day, every month, every, whatever their time segments are. So a decrease of 60. Got it? Number 3, the number of members in a baseball club increased by 45% every year over a period of X years. Which graph, it should say, best represents the function? All right, so first thing, the easiest thing to do, you guys, is look for the y-intercept. So remember, the y-intercept in a situation like this is that first number. So this number is showing our increase or decrease. So since this is a number greater than 1, our graph will definitely have an increase, a growth. So if it's increasing by 45% each year, we would have added 1 plus 0.45, which is 1.45. But this is our y-intercept. So if you know that, you don't even have to really investigate the graphs very much at all. There's only one that shows us our y-intercept. That is our starting or our initial value. Okay, so that's it. That's all you need to know. All right, so number 14, we have a square and each side is 3 raised to the 1/2 inches. So 3 times, or 3 raised to the 1/2. Basically, to find the area of a square, you're going to multiply base times height, right? So how could I write that? Well, I could turn these into radicals. So 3 would go under the radical, and the numerator stays with the 3. My pen is not liking these numbers. And then the 2 becomes this number right there. So we can multiply basically the square root of 3 times the square root of 3, right? Well, the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? 3. So the answer is 3 squared units. Okay, so that is the area. So just turn those two numbers. So that's not 3.5 inches, guys. That's not what that says. It's 3 raised to the 1/2 power times 3 raised to the 1/2 power, which is the same thing as saying the square root of 3 times the square root of 3, which is 3, because square root of 3 squared is 9. Square root of 9. All right, number 15. So we got to convert all this stuff to exponential functions in order to multiply the top and then divide by the denominator. So we're going to turn that first 5. So our base is going to be a 5. It's raised to the numerator is going to be a 1 because that's the first power. So this is 5 to the 1/3. This is a multiplication problem times 5 to the what? 1/2. And we're going to divide it by 5 to the 3, but stays our numerator, and the 4 becomes our denominator. So the top two numbers are being multiplied, so we're going to add those exponents. And then when we divide numbers, we're going to subtract the exponents, right? So first thing we're going to do is add. So we need a common denominator. So 1/3 plus 1/2. I think we've already added these numbers today. So we have 2 6 plus 3 6. So this is going to be 5 and 5 6 divided by 5 and 3/4. So now we're going to subtract. The rule is to subtract exponents. So once again, we can use we could use a 12 for our denominator. So we're going to have 10/12 minus 9/12, which is 1/12. So the final answer is 5 to the 1/12 power. 5 to the 1/12 power. Number 16, what would be the difference of these two functions when graphed? So look how this one is. Look at this one. What would be the difference in these two graphs? Well, the second one's y-intercept. So this one's y-intercept would be 4 units higher. 4 units up, or 4 units higher, 4 units, I guess higher is a good, woo, I wish I could write and spell. So the y-intercept is going to be shifted up. That's even a better way of saying it. The y-intercept would be shifted up 4 units. All right, number 17, I'm going to clear all this stuff off the screen because you can always go back on the video. So number 17, which function goes through the points 2, 27, and 4, 6.75? So basically, imagine that we have a t-chart and it's given us 2 points. So we have 2, 27, and 4, 6.75. So basically, since we have a formula, well, we have all these formulas to choose from, we're simply going to, oh, and they want this to be n, sorry, this would be the f of, this would be n, and this would be f of n. So we're simply going to take these numbers in the n value and we're going to plug them into this n right here. So let's use our calculator and we're going to multiply 108 times 0.5 raised to the, so if n is 2, 2 plus 1, we would raise that to the 3rd power, and I get 13.5. Well, that's not the right answer because I'm looking for 27. So A is out. So let's try the second one. So 54 times 0.5 raised to the n. Well, the n is 2. That's also 13.5, which is not 27. So that one's out. So let's try the third one. 54 times 0.5 raised to the n minus 1. Well, n minus 1 is 1. 2 minus 1 is 1. So 54 times 0.5 is 27. So that one works. Let's just make sure the fourth or the other coordinates work as well. So 54 times 0.5 raised to the 4 minus 1 is 3. So sure enough, that's 6.75. So this one is the right answer. All right, so that's all the problems I have for us to do together. Now, please read my last sentence on this slide. I recommend that you review last week's growth and decay video. It was labeled 2 dates. That one video said the 11th or November 9th and 10th, and the other video over sequences. So both of those would be great reviews for you as well. So today, that's what you need to spend your time doing. You just watch this video, good for you. Go back and watch those 2 videos and look at those practice problems. And if you'll do all of that today, you're gonna do great on your test tomorrow. All right, guys? Well, good luck to you. If you need my help, you need some more review, you have a question on anything, send me a message and we can get in touch with each other, okay? All right, guys, good luck tomorrow. See you later.